bounties. We had looked at the first Zama bounty, which looks at how to enhance the library, the fully homomorphic encryption library. Now, so we went through some of the things we can try to do, and so that we enhance the library. And then, for instance, we talked about if you wanted to multiply, for instance, polynomials, you could multiply polynomials, and then think of how, although they do multiply polynomials, but the speed at which the process happens is slower. So then you think of how can you speed up that process. Or you can also think of even a division of polynomials and how to speed the process. So that is when you are dealing with the integers, and then you're talking about operations on integers. Where operations on integers could be addition, could be multiplication, or even division. So those are, you can talk of integers, you can talk of polynomials, and so on. If you're given a polynomial, you can multiply polynomials, you can add polynomials, and you can also divide polynomials. You can also think of a way of, for instance, encrypting data and then decrypting data. You write a code for doing that. And this code should allow such that it's possible to encrypt an already encrypted data. So as you write that code, you make sure that is possible. And again, look at how fast the speed, look at the speed. Now, so I tried to write a code for polynomials, but I've not tried to check the speed, whether it's efficient compared to the ones they have. But I just wanted to show you. But you can also write even addition and so on, but try to improve. So mine, I used a Fourier transform, fast Fourier transform that we talked about last time. It's a process that can speed up multiplication of polynomials. So this library, you can see the code. Is that okay?
Yes.
Yes, this library you just import it from the Zama. They have this on their website. They have this this library. My function has this polynomial, these two polynomials, and the ones I want to multiply. So this is like the first one is just like 1 plus 2x, then plus 3x square. So this is just the same as 1. It's just 1.0, which is just 1, plus, so 1 is a constant, then plus 2x plus 3x square. That is a polynomial. Then you have this other polynomial, which is constant 4 plus 5x, then plus 6x squared. So when you multiply this, let us see what it gives us. Although we know how to multiply polynomials just the same way you are multiplying quadratic equations while in high school. But I'll have to show you that. But now when you run, let's see how it runs. When it runs, it gives you a result here. Gives a result here. This process, it takes some time. It's not as fast as it has done, but it takes some time, as has given us some result. Now, so what is required for you is once you've written this code, you're supposed to try and benchmark. The benchmark means you want to compare your code to what exists, to what they have in their library. So you want to just compare, want to see whether yours is faster. If it's faster, then you've achieved what they want, because they want something that can also be, they want something that will be faster for them. Now, if it's not faster, then you can do what they call profiling. Profiling is now you checking where your code is slower so that you can improve at those where it's slower. So how do you benchmark? To benchmark, you just come, you create on this route where you're seeing SRC, main, and so on, target and cargo terminal, you create here a bench, and then there's a code you put, you create a code, and the website gives you direction on how to make that the codes. Although for them, once you submit this to them, they'll benchmark it at Amazon. They call it Amazon something. There's Amazon something. That's where they benchmark their where they'll benchmark finally once you submit to them, so that they see whether your code is faster, is better than what they have. Now, but for you can just do local. Local, I've said you can create some directory here, a bench. To create a directory here is just, if you come here, you can see here where I'm pointing. Can you see where I'm pointing? On the left side.
Yes.
It's written new file, but what we want to create is new folder. Is the next one, new folder. So if I click on that, use my space here to create new folder. Okay, or alternatively, while inside here, if you did right click, what options do you have? We have a new folder here. We have a new folder at this point. So when you click on it, again, it gives you a place to write. So I wanted benches. And so I have benches, and inside these benches, I can create a file where I want to input the code. Where I want to input the code that I want to try. That code, I'll tell it what parts from my code I want tested. What parts I want tested. So those parts I want to test for their speed and see whether their speed is better than what exists. So I'll come to these benches and then now create a file. This file, I want to call it benchmark. Benchmark.rs. So if I say benchmark, says the name benchmark is not valid as a file or folder, please choose a different name. But it's benchmark.rs. So if I would have stopped there, it would not have accepted. So I have created this benchmark. It's inside benches. So inside benches, I have this benchmark.rs, and you can see it opens where I can input my file and that file, if you go on their website, they have a way they tell you how to make the code for the benchmark.rs. Now, I've said that this benchmark.rs will be assisting you to just no, it will be assisting you to tell whether your code is functioning better than what they have on their website. So that if it's functioning better than what they have on their website, then you're okay. You're okay. You can submit with confidence. Now, if it's not functioning better than what they have, what I've said is that does not mean that your code is inferior. What that means, therefore, you want now to do profiling. And profiling is trying to understand which part exactly is lower in terms of speed. Now, so for you to do profiling, what do? You come to where we run here, at this point where we run, and we want to install it. So to install it, you type cargo install flame gap. So let's see what happens if I do that. If I say run, so it's cargo install that. Will not find flame gap. I was supposed to do. I've not inserted the code in benchmark, so that is why. That's why it gives me this. It's not supposed to be. Just a minute. It's not. Let me do it again. It's supposed to be flame graph. Flame graph. Now, so it says flame graph is already installed. So that means you are ready now. You can now do. You can find out which parts are slow. And so for you to do that, now you come and just say, hey, we've already installed. Now say cargo flame graph. And when you do that, it runs. Then it will, after running, supposing that we had put here the code for benchmark, after running, it's supposed to tell us which parts are slower. Now, so the importance of this is that once you know which parts of your code are slow, you again think of how to improve them. You again think of how to improve them. So that is the important thing about this. So, and again, the thing is, you can make as many codes as you can. They don't have a limit on how many you should submit. That means if you try one and you think it measures to some threshold, it measures to some point that you feel is you can submit that, and again you create another one. You can create as many codes as you can, so that and again that the importance of that is it may increase your chances also. That's the importance of that. So you can try one and submit, try another one, submit, try another one, submit, and so on. So that is about the first that was supposed to see how to improve the library. Now, so there's this other one. This one again, this one now is supposed to create a privacy preserving image style transfer. What this means is that supposing you wanted to transfer some image, which is a photo. So they want you to create a code that can assist to transfer that, so that as this image is transferred from one place to the other, it's its privacy is preserved. Its privacy is preserved throughout all this process. So that supposing we had intruders who wanted to see what it is, they cannot see it. So it's encrypted. It's encrypted all through. It's encrypted all through. So now for this one, I've not created the code. I've not created the code for this, but now they have given us what to, how to do that. We are supposed to use the concrete ML. Concrete ML is what we are supposed to use so as to create this image preserving transfer style. Now, what does the concrete ML do? It facilitates the data scientist usage of the fully homomorphic encryption. And so what that means is that this is used as a tool. It's just a tool that simplifies the implementation of the fully homomorphic encryption for data. So supposing that we have this data scientists that want to implement fully homomorphic encryption, then and this one again you find it on their website, on the website of Zama. So the website of Zama has this concrete ML tool for us to use. So again, what that means if this is the bounty that you want to work on, you go to their website and get the cargo tomil that you add to your, even for the previous that we've done before, the previous one you are getting cargo tomil from the website, the one you'll put on in your cargo tomil. Let me share another one that I already have put the cargo tomil. Just open another one. The cargo tomil. Let me just find the one that I was working on today. Okay, maybe I'll share it later. I can't see it here. I had not opened it. But what I mean is their website has a lot of information that is very important, and try to interact with that website and understand what you can get from their website. Understand what you can get from there and then use it. Now, the code is just yours. The code is yours, but you'll have to import, you'll have to get the cargo tomil to use. So cargo tomil for this again is provided on the website. Now, so what do we mean by style transfer? Style transfer, what is it? So this is just a computer vision and graphic technology that generates a new image by combining the content of one image with the style of another image. So what we mean is, you want this image not to be identified by anybody. So supposing I have this image A, and I have another image B, but this is my image of interest. This image A is my image of interest that I want transferred from one point to the other, and I do not want it to be recognized by anybody. So then I come to this style transfer, and under this, what I do is that I will take this image A, I'll take this image and combine its content, the content of image A with the style of another image. Let me say image B. I take some style here from image B and then combine with that image A. Or I can even take style from several images, and then combine with the content of this A, and then transfer that. So that means anybody seeing that may not be able to recognize what it is, but once it reaches the intended person, then it's supposed to have put there a mechanism of now producing the A as it is, producing A as originally it was. That mechanism should be there. So the goal of style transfer is to create an image that keeps the original content while taking on visual style of other images. So that if I look at it, if somebody looks at this A, our image A, can see B, can see C, can see D, and what comes to the mind of this person could be A, could be B, C, and that's what the person is seeing. But you know you have your A. So you've mixed this A with the style of B, style of C, style of D. You can have that from several other images. Anybody seeing this would be not be seeing A as such. Would be seeing the styles of A, B, styles of C, and so on. But what we know is that the original content has been kept, is still intact. The original content is still intact. So when it reaches the intended person can be able to see A as it's supposed to be seen. So this is just mixing these styles is just meant to ensure that the privacy of A is kept, is preserved. That is why we have to mix those. Now, so there are various methods for mixing these styles. There are various methods, and again, these methods are provided on their website. And one of the method, the one that is mostly used, is the conventional neural networks, which is abbreviated as CNN. And the examples are this and this. I hope you know these ones more than I do because you are from the line of computer. So these things I hope you know them, but you can still Google and find out what they are. You just Google conventional neural network, and these will be the examples. And of course, this is the easiest to work with. For those who will be choosing on this bounty, this first one is the easiest to work with. We also have the encoder-decoder networks. We have the perceptual loss networks, which uses a loss function based on feature maps. So there are several architecture. There are several ways of mixing these styles. And of course, I've said the first one is the one that is easier to use. Now, style transfer frequently entails processing personal images, such as photos of humans, which may contain sensitive data. So because of that sensitive data, we want to ensure that as we transfer, we employ style transfer technique. That style transfer technique employed is supposed to preserve that sensitive privacy of that sensitive data. So protecting the privacy of these photographs is very critical to avoid illegal access. So that is why that protecting is very important. Unauthorized access to photos can result in a variety of security problems, including identity theft, phishing attempts, and all other harmful behavior. So this, I think you're familiar with this identity theft, where somebody can even, I've seen nowadays somebody takes somebody's photo and pretends that is the owner. Then he creates some WhatsApp group, some WhatsApp, and then starts calling people, asking for money. So when you look at that photo, you think that is your friend, and in the real sense, is an imposter. So I think we identify with this. We identify with this behavior, harmful behavior of identity theft. So there are various things that people can use when they get the photograph illegally. So that is what we are trying to prevent in this. So your task, what is your task in this bounty? What is your task in this bounty? So what I've highlighted above is what you are required to do. What is your task? Your task is to build a style transfer application. And you're using Concrete ML, which I said is found on the website. And then protect data privacy along the process. So your task is to build a style transfer application using Concrete ML while protecting data privacy along the process. So as you build this style transfer, ensure that data privacy is protected. And again, as I said, at the end of your code, you'll have to benchmark. To benchmark means you'll be running your code, and when you go to the website, they have, for instance, let me talk about the integers, multiplication, and so on. When you go to the website, they have produced a list of the speed of various functions. The speed of multiplying, let me say, 32-bit integer by 64-bit integer, the speed that that process takes in their library. And the speed of dividing polynomials, they have that. So we have that list on the library. So what you are doing to benchmark, you run yours, then you use your benchmarks code will now give you the speed of yours, your calculations. Then you go to the website and compare your speed versus theirs. Compare your speed versus theirs. So you'll be able to tell if your speed is slower or faster. So if you've discovered that yours is slower, then you think of how to improve it again. That means you've not reached their level. You need to at least be above their level so that you qualify to have contributed to their library. The same thing with this style transfer. The same thing with this style transfer. After you've done this, you'll have to again do benchmark using a code, benchmark code, and then that benchmark code will give you the level of your, for instance, although I've not tried this one, but it's supposed to give you, I think it's supposed to give you how protected your the privacy is, how I guess, and then yeah, so that you then compare yours against theirs. And when the code reaches them again, they'll still do benchmark on their own. Your code, you find your code and then run against theirs so that they see whether you meet the requirements. Now, so your job, I've said your task, your job is to create a pipeline that takes an image and modifies its style. So you have an image A, modify the style of this A using other images. So that is your job. So after you created that code, you should be able to do that. So the style can be established in the model or by referencing the second image. So for instance, you have another image B in your code, you have image A in your code, and then you just reference a style so that A, the style of A you reference to that other so that it can copy the style of B, can copy the style of C, and so on. Now, in the second scenario, one image is utilized for content and another for styling. One image is so we have the content and then we have the style. The style, I guess, would be the outward appearance, I think. That would be the style. So that what somebody can see from outside is what you want to try and ensure that nobody's seeing it. The system should create a new image. So you have image A. So you're now creating a new image. And this is just camouflage so that nobody can see that it was A. So the system that you're producing should produce a new image that integrates the first content with the new style, all while ensuring that data remains secure and is encrypted all the time. So that is what you'll be doing. That is what you expected to do in this bounty. Now, for them to reward you, what they expect are the following. You are expected to demonstrate the effectiveness of your solution by providing examples and discussing the trade-offs you made to make your model compatible with the FHE computation. Now, these trade-offs is what I explained last time. I explained last time that one choice may be faster. Another choice is slower, for instance. And so then you're thinking of how do you take the middle so that you don't take one that will slow the speed. Or will, for instance, you may choose process A, which increases the speed. And as it increases the speed, at the same time, it may be producing a lot of noise. Maybe a lot of noise in the process. And you know, when noise accumulates, encryption process stops. So by trade-offs, what we mean is, although you have this method that will have increased speed, this same method reduces encryption process. So there's something you have to give and take. So it's called give and take. So you relinquish something, then you take another one. That is what we mean by trade-offs. So there's something you had opted and then you leave it, or you reduce, go for the middle where they merge, so that it does not increase speed and then reduce encryption process, so that we have both processes going. That is what we mean by trade-offs. So what they mean is that where there are such trade-offs, you'll have to discuss. You'll have to say, for instance, this option was better, but I didn't use it. I went for the middle part, for instance, where the speed is moderate, and at the same time, encryption process, it continues. Unlike taking this, which is as a very high speed, but then the encryption process stops. So those are the trade-offs which then you have to discuss, so that they also understand why you chose on this and not the other one. Now, so the first expectation after knowing what you're supposed to do is that you're supposed to make the task manageable. to a common PCs. Should be manageable to a common PCs. The input images can be small. For example, this size, 32 by 32 or 48 by 48, which works well for portrait pictures. So you'll have to, so this is one part where trade-offs comes in. Because when you take smaller sizes of these photographs, the speed would be higher, but now the quality will be lower. So now trade-offs are coming in. So you then justify why you take which size. And if you take bigger sizes, the quality will be very high, but now the speed will be slow. So that is why they say to make the task manageable. To make the task manageable on PCs. So it should be one that can be managed on PCs, and so that not one that will not be managed. So that means you look at the sizes and see which sizes to go with for your photograph that you're using. Now you may perform some pre-processing steps to clear data before running the FHE style transfer. Approaches that only perform a forward pass of a neutral network to do style transfer should be most amenable to work with. Now, so this ones, you just get them on the bounty. Under the bounty, as Alex was showing you the other time, we have what we call the overview. Is it overview? Yes, where they give you the general generally what the bounty is about. They tell you what the bounty is about. Then under that, we have you are expected to. So these are the expectations that they have put on the website of what you're supposed to do. So again, you read through these expectations and then understand. Now, what should your submission contain? What should your submission contain? So this one, again, when you go through the website properly, you then get it. While you've come up with your code and you're ready to submit, your submission should have a report of the method and the technical choices you made. Technical choices you made. And you remember we talked about the trade-offs. Those trade-offs where you're saying, I made this choice and not this choice, or I came in between and took this position because of the following reason. So that is what we call a report. And this report is giving, and then we have a notebook, and I'll show you how that notebook is drawn. And the notebook shows, showing off your model on some images. I'll show you how that notebook is written, and that one is also supposed to have those two. So you'll be submitting this report and also the notebook. Now, so after that, then I thought of what are the steps in creating. So what are the steps in creating privacy preserving image style transfer application using this congruent ML and fully homomorphic encryption or FHE. So I thought of what could be the steps so that if you follow these steps properly, then you should be able to do this. The first step is understand the requirements. Understand the requirements. So what are those requirements? First, privacy preserving. Understand what that means. And so what that means is that you will have to use the fully homomorphic encryption to ensure that the image data remains encrypted throughout the process. So when you understand that, it's okay. Then the other thing you're supposed to understand, the other requirement is style transfer. That is the other requirement that you need to understand. What does this mean? It means you'll have to use neural network architectures that we've discussed above to combine the content of one image with the style of another image or other images. The style of another image or other images. So you also need to understand what style transfer is. So you need to understand what privacy preserving means. So this, I'm just taking this from the definition of the bounty. The bounty says, the name of the bounty is create a privacy preserving image style transfer application using concrete ML. Create a privacy preserving image style transfer application using concrete ML. So then I'm breaking down just breaking down the terminologies used in the bounty. Concrete ML, again, you need to know what it means, what it does. It leverages this framework to convert machine learning models into their homomorphic versions. So that is what it does. But the good thing is that the code for concrete ML is provided, not the code, but the cargo tome is provided on the website. So you just come up with a code. Now, so what am I looking at? I'm looking at steps that we should follow to create a privacy preserving image style transfer application. And the first step is to understand the requirements. And we've gone through the requirements. The second step is to choose a neural network architecture that you will use. And these ones, we've discussed them above, and of course, they are on the website. These are what I'm referring to, these styles. You choose one. Choose one that you use. So that is what the next step is. That is what the next step is. Choose a neural network architecture that includes this. These ones, you already looked at them. So you choose the one you're going to use. Now, of course, I've given here something. I've said that given the FHE constraints, the first architecture is more straightforward. And I'd already explained. Given the constraints, this one is more straightforward. But we're not saying that it's the only one to be used. You can also try to use these others. But this is more straightforward, it's easier to use, it's easier to implement. But these others, so then it means they'll be more demanding. But of course, they're achievable. They're achievable, so you can also try them. The next step that you can now, the next step for you to produce what they want is to design a workflow. Design a workflow. And so the first part of designing workflow is the pre-processing on clear data. So under this pre-processing one, we do image resizing. Image resizing, and remember we talked about these image sizes. If the image is smaller size, the speed will be faster, and now the quality of the image will be low, and so on. But we want to balance. So you do image resizing. So you scale down images to this to make computations manageable. You scale down. Then do normalization. Normalize the pixels values to fit within the range required by the neural network. And then we have the model conversion and encryption. So you convert the model and then do encryption. So what is this model preparation? Under this, shall we be doing? One, you select a pre-trained, that is if you chose the first architecture. If you chose the first architecture, then you would select either this, because there are several examples under that. Select one, then modify the model for the style transfer tasks. Modify it. Of course, these models exist. They already exist, they have already used them, but their speed and so on and the level of noise is demanding. So that is why they want people to come up and try to assist them. So you have this model, just take the model and try to modify and see whether the speed and the noise are managed. That's what we mean by modifying there. It's already there, so you're not coming up with a new one. And then integrate with the concrete ML. Integrate with the concrete ML. So to integrate here, you use the concrete ML to convert the model into its homomorphic version, ensuring that all computations can be performed on encrypted data. Then do style transfer computation. Now, to do this style transfer computation, the first thing you do, encrypt both content and style images using fully homomorphic encryption. So encrypt, remember we said that as you work on these images, ensure that as you do that, they're encrypted all through so that their privacy is preserved from the beginning to the end. So you encrypt both content. The content is of the image you want to, supposing it's image A that you want to transfer. Its content must be encrypted. And then you are borrowing styles from images B and C. You're borrowing styles from images B and C. The content is of the image you want to transfer. Encrypt that content. Encrypt the content so that it's preserved. That image is preserved. And then the styles you're borrowing from B, C, and whatever image you're borrowing, encrypt those styles also. Encrypt those styles. And then, of course, you'll have to mix. You'll have to put that style on an A. But that style must be encrypted. And then perform the style transfer operation on encrypted data using homomorphic model. Then decrypt the output to obtain the styled image. Decrypt. So you're decrypting this. So that the essence of this is so that it's possible that the person it's being transferred to can also decrypt. Of course, you can send something that cannot be decrypted. So you try your model, try it and see whether it can be decrypted after encrypting. And then when you decrypt, see whether you only seeing A or you are seeing A combined with those styles, because you're supposed to see only A. The styles were just meant to camouflage this. Now, after you've done that, you then write the Rust code to include pre-processing, model conversion, and encryption, and then style transfer computation. Now, so after you've written the Rust code, you do evaluation and trade-offs. We had already talked about this. Now, what is under this? The effectiveness. You test the model with various images to ensure that the style transfer works correctly. So that means, okay, you are working with the image A, take another image again and try. Take another image F and try again. Try with as many images as possible, because your model could be one that can work with only one image. Let it be possible that given any image, your model will still produce correct results. That is why you evaluate. This is what I mean by evaluation. Evaluation means, and that's what we talked about. Yeah, evaluation here, you are trying to find out whether your code and your model works before you submit. You're not submitting something that you've not tested. Test performance, evaluate performance of your model. This means ensure the time taken for encryption, computation, and decryption. Measure it. Yeah, measure the time taken for encryption, computation, and decryption. Of course, when you measure this, as I already said, you go to the website, they also have their times. Compare your time against their time and see whether yours is an improvement. If it's not, I talked of profiling. Profiling will give you the specific points that are letting you down, the specific points that are not performing properly. Improve on those points, and then again measure the time. So measuring here, it means as you submit your code, you are aware that it's going to compete. It's going to compete with others. So after your code is ready and the model is already, evaluate the effectiveness, evaluate the performance, measure the time taken, and so on. Then come the trade-offs. I'd explain that. So you're comparing. You want to see which one not to take because of what reason. For instance, when you look at the model complexity versus the FHE constraints, if you find that they are not, if you pick this if you pick both of them high, they not produce the required results, you simplify the model. Supposing if the computation are too low, if the computation are too low, if the computation is too slow, if the computation is too slow. So supposing it's very complex, and of course we have the constraints. So if it's very complex, you discover that if your model is very complex, you discover that maybe the computation will be slow. The computation may be slow. So if it's slow, you make it slightly less complex. But as you do that, ensure that the speed is still above what they have. So you don't make it very less complex so that your speed is faster, for instance, and maybe the quality is low. So those are the things we are looking at. So as you reduce, ensure that it can still perform better than what exists. That's what I mean. Ensure it can still perform better than what is already in existence. Look at the size versus computation. The size. When the size is very small, you find that sometimes the computation, the speed will be high. For instance, the speed will be high. But now, what about the quality? What about the quality? The quality might be low. So that tells you again, you have to do some trade-off. That tells you there. So I've said here, if you compare image size versus computation time, smaller images reduce computation time, but may affect style transfer quality. So those are the points. Then we have documentation and reporting. Documentation and reporting, that's the last thing that you're supposed to do. So document your approach. Document your approach, write your approach. Also document your model selection. So you're writing, you're telling them why you're choosing this model. Document your pre-processing steps, the steps you used. Document your FHE integration and any other trade-offs made. Document them so that they'll all be, you'll hand them, all of them, to as you submit your work. Now, this is an example of a notebook. Look at this example of this notebook, what is entailed here. It begins with the privacy preserving style transfer code. That there's this introduction part. The introduction part says, this project demonstrates a privacy preserving image style transfer application using Concrete ML to leverage on fully homomorphic encryption. Methodology. So I have put here the method I used. This is just an example. Under methodology, I've said my model selection. I've selected this model pre-trained on ImageNet. And then the pre-processing images, I've resized my images to that and then normalized. I've done FHE integration, and by that, I've converted the model using Concrete ML. So I'm just telling them what I've done. And then style transfer, I've performed on encrypted data. And then decryption, final output image decrypted for visualization. So I said, of course, you should be able to decrypt your image. Then the results, example images, show before and after images. So you show the image before and then the image after, so that they see after decryption, does it look like what you had? Then performance metrics and so on. So most of these things, you'll get them information on their website. So they guide you on the website on what you're supposed to do. Then it discuss trade-offs. And this is the notebook I had said I'll show you. It's an example of a notebook, and the one I'm using is called a Jupyter notebook. This is the one that I chosen. Okay, any question or addition? Now, so as I said, and let us begin working on this. As I said, we can submit as many codes as possible. And of course, that also means that you can submit for bound A, also come submit for bound B, and also submit for bound C. You can even decide to submit 5 results, your 5 findings for bound A, and then submit 10 for bound B, those are codes, and of course, submit 20 for bound C, there's no problem. But if you don't want to submit so many, you can just work on, can just measure on one and perfect it. And that is also another way. So that we give ourselves some time, just like 4 days, 5 days, and so on. We see whether we can perform that. For me, I've started and I've tried the benchmarking. That is where the problem is. I still have a problem where the benchmarking part, my code is not giving me results. So I still have a problem writing the code for benchmarking. So that when you have the code for benchmarking, then it can tell you whether you are even ready to submit. If it tells you that your speed is even higher, because it will give you the speed for your operations. Give the speed for operations, then you compare your speed versus what exists on the website. And if you see that your speed is an improvement, then you are ready to submit that code. Of course, one thing I read on the website, they said that they'll not be rewarding people for the time they spend to write the code. That's one thing I read. They say they'll not be rewarding people for the time they spend to write the code, but they'll be rewarding them for working out to improve on their library. So if it's an improvement on their library, they reward you. But for just having worked hard and tirelessly and spend sleepless nights, that one they'll not be rewarding. Thank you. That is what I wanted to share today.
Thank you, Dr. Sakwa. I think I can ask first Simon to stop the recording so I can share something. Simon, you with us? See just a moment. Just call Simon a bit.
Yeah, I think I can also stop the recording.